So if you have any, I'll provide you with the notes. If you have any doubt, then please let me know in the next section. Today we are going to start a new chapter, that is acids and bases. Is it fine for you?
Yes.
Okay, so today we are going to start about acids and bases. So can you tell me what do you know about acids, what are acids, and what do you know about bases?
I know acids have a pH of
Mhm.
6 going down, and bases have a pH of 8 going to 14.
Okay, so
And
that
then
is
I
on
also
the
know
basis
that
of pH scale.
yes, I also know that acids are corrosive, so are
Mhm.
bases. I know that acids are sour and bases are bitter. Um, I also know that a base is anything with oxygen or hydroxide.
Yes, hydroxide ion which releases hydroxide ions in the aqueous solutions, right? And the hydrogen acid are substances which release your hydrogen ions. So you can see here these are three images. We have probably seen this acid in the lab. It is dilute nitric acid. It is concentrated hydrochloric acid, and this third bottle is dilute sulfuric acid. So basically, these all are the solutions of their pure compounds in water. Okay, nitric acid. The formula for nitric acid is HNO3. Hydrochloric acid, it is HCl, and sulfuric acid is H2SO4. Hello, Silachemba. Welcome to the session. How are you? Today we are starting a new chapter, that is acid and bases. So I hope the organic chemistry chapter is completed, right? And if you have any doubt, you can let me know. If you have, you can write down the question in the chat box. I'll provide you with the notes of the organic chemistry. Okay, so please learn it, revise it. Today we are starting a new chapter, acids and bases. So here we have three bottles of acid. You can see this is dilute nitric acid, this is concentrated hydrochloric acid, and the third bottle is dilute sulfuric acid. The formula is written here. It is HNO3 for nitric, HCl for hydrochloric, and H2SO4 for sulfuric acid. So they all are the solutions of pure compound in water. They can be dilute like this or concentrated. Dilute means where the concentration of water is higher. Dilute means where concentration of water is higher. Okay. And concentrated means where concentration of water is lower. Concentration of acid is higher. Where concentration of acid is higher. Okay. Now see the second image. This image, you can see that we have, this must be handled carefully, especially the concentrated solution. Okay. So this is a cloth in which acid is spilled. Acid is corrosive, as Tino has told me that acids are corrosive. Okay. They can eat away metal, skin, cloth. If okay, that's why we have to be we have to take very large precautions while handling these acids, especially the concentrated acids. They are very corrosive. But there are some acids which are not so corrosive, even when they are concentrated. Even when larger amount of acid is present, then also they are not concentrated. These acids are called weak acids. Okay, so we have two types of acids, strong acids and weak acids. Strong acids are highly corrosive. They can eat your metals, they can eat lungs, skin, and throat. But if we talk about weak acids, then they are not corrosive. Even in the concentrated form, they are not corrosive. Example of weak acid, if I ask, then you have to say it is ethanoic acid, which is found in vinegar. It is a weak acid which is not corrosive. Example of weak acid is ethanoic acid. Example of strong acid is sulfuric acid, nitric acid, hydrochloric acid. Is it clear? Write it down, whatever you want to write from here.
When you're doing organic, did you guys do polymerization?
No, not yet. We'll start polymers after completing acid and bases, okay?
Yes, ma'am. That's the topic which I have doubts with.
Okay, no problem. We'll quickly cover this topic. This is a small topic, acid and bases, and then we'll start with polymer.
Yes, ma'am.
So, have you done Silachamba writing? Okay. So how can you tell if something is an acid? You cannot even taste it, right? Because it is very harmful. So you can tell if something is an acid by its effect on litmus. Litmus is what? Litmus is a purple colored dye. It can be used as solution or a paper. So litmus solution is also there, litmus paper is also there. So if we take any unknown solution, okay, and if we put it on the litmus paper, if the color of litmus paper changes to red, then we say that your solution is acidic. So what you have to remember that acids turn litmus paper red. Okay, when litmus is turned red, so we may know that yes, acids are present. What is litmus? It is a purple dye. So the question may land up: how can you tell if the substance is acid by using a litmus paper? So you can easily answer this question in your exam. Okay, so the common acids. If I ask you the example of some common acids, okay, so this is hydrochloric acid. You should know the hydrochloric acid is HCl. Sulfuric acid. What is the formula for sulfuric acid? H2SO4. What is the formula for nitric acid? HNO3. What is the formula for ethanoic acid? CH3COH. And you know H. We have studied organic chemistry. H means two carbon atoms. One is this and second is this. And oic acid means carboxylic acid whose functional group is COOH. This aqueous means that it is dissolved in your water, where water is solvent. So you should know the formulas of all these acids. Where hydrochloric acid,
Sorry, ma'am.
sulfuric acid, and nitric acid are strong, and ethanoic acids are weak acids. Yes.
Sorry, ma'am. You say the aqueous means?
Aqueous means where water is solvent, where water is present in a larger quantity.
Yes, ma'am. So you say the first three are strong acid and then the last one is a weak acid.
Yes. All these are your strong acids. They are corrosive, while ethanoic acid is weak acid. Strong acid means it completely dissociates in water. It completely, when dissolved in water, for example, like this, it completely gives your H plus ion and Cl minus ion. So this is a complete dissociation.
Ma'am, how about when it's not completely dissociated?
Then it occurs
How
like
about when
this.
it's not?
Then it is an irreversible reversible reaction CH3COH. It is a reversible reaction CH3CO minus plus H plus. It is not completely dissociated, it is partially dissociated.
Yes,
Because
ma'am.
it is again converting into your acid.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
If a single arrow is there, that means it is completely dissociated, which is a strong acid. And if there are two arrows, reversible reaction, so it is PA, means partially dissociated. Sorry, it is weak acid, WA. Okay. So the next thing is lemon and the lime juice. It contains citric acid. Always remember, I'll ask in test that which acid does lemon and lime juice contain? It contains citric acid. Then Arnsting. Which acid does Arnsting contain? It contains methanoic acid. Okay. And fizzy drinks, cold drinks. It contain which acid? Carbonic acid. Carbonic acid is formed when carbon dioxide it is dissolved in water. Then we have it is H2CO3. It is known as carbonic acid. It is present in your fizzy drinks. You should know that citric acid is present in lemon and lime juice. Methanoic acid is present in Armstings and carbonic acid is present in your fizzy drinks.
Ma'am,
Hmm. Yes,
is
Tina.
that why it says is that the Coca-Cola
Yes.
drink on Pepsi?
Yes, both drinks. Your cold drinks, okay, any brand, it contains your carbonic acid.
Yes, ma'am. Ma'am, I once came across this question. Okay, I'll just I'll just look for the question and then send it in the group.
Okay. Which
It was
chapter?
something about methanol and carbon dioxide, and then the question was something like which one warms the air and destroys the ozone layer.
Okay, so what
really
you can do
remember the
is,
question.
please send the question in your respective WhatsApp group. They will send it to me and I will explain you in the next class. Is it okay?
Yes, ma'am.
So have you written this slide, Tinu?
Yes.
Next is alkalis. So we have read about alkalis. Now what is the effect of alkali on the base? Sorry, on the litmus. It turned litmus blue. So remember, acid turned litmus red. Alkalis turn litmus blue. Like acids also, they must be handled carefully. They too can burn corrosive. They also may be corrosive. Okay, so alkalis are what? They are base which are soluble in water are known as alkalis. Base which are soluble in water are known as alkalis. Example we will see in the next slide. Okay, so some common alkalis you can see here that these are my common alkalis. Sodium hydroxide, formula for sodium hydroxide is NaOH. Potassium hydroxide is KOH. Calcium hydroxide is CaOH2. How? Write down calcium, write down hydroxide. Valency of calcium is 2 because it belongs to group 2. The valency of hydroxide ion is 1. So cross multiply and then you get your formula. Ammonia is also a base. Okay. So the pure alkalis are solids except for ammonia. Ammonia is a gas. Okay. They are used in lab as aqueous solutions. The solution of calcium hydroxide in water is called lime water. When you dissolve calcium hydroxide in water, then it is called lime water. Yes.
Ma'am, what's the difference between is it like the difference in state that causes the difference between lime water and limestone?
Yes, there's a difference. Limestone is calcium carbonate. Okay, but lime water is a solution of calcium hydroxide in water. This is my limestone, calcium carbonate. This is limestone. Okay, calcium carbonate. But what is lime water? It is a solution of calcium hydroxide in water. So you can say calcium hydroxide in aqueous state. It is your lime water. And also these three are my strong bases and ammonia is a weak base. The solution of calcium hydroxide is called lime water, and another word it is also called as flaked lime. Flaked lime. So there are two words here. Calcium hydroxide in water. And how it is produced, calcium hydroxide? When calcium oxide reacts with water, it produces calcium hydroxide. It is in the aqueous solution. So this is known as my what? Lime water. Okay, and the chemical formula for slaked lime is CaOH2. Next is our indicators. What is an indicator? Like litmus, it is also an indicator. Why? Because indicator, as the name suggested, it indicates something. It indicates whether something is an acid or alkali. Okay, so what is an indicator? It actually indicates whether something is an acid or alkali. Example of indicator is litmus. Okay, like see, we have three indicators which are in your syllabus. First is litmus, second is phenolphthalein, and third is methyl orange. Okay, so they changes color. Basically, they indicate whether something is acidic or alkali. So litmus color in acid is red. Its color in alkali is blue. Okay, but phenolphthalein in acid it is colorless, but in alkali in base it changes color to pink. Methyl orange in acid it is red, but in alkali it changes color to yellow. So you should remember all these colors, all these indicators and all the colors in acids and bases. So please write it down. Make this table. These three indicators are very important. You know what are neutral substances? So there are some substances which are not acids, which are not alkalis. They are neutral. For example, pure water, it is not an acid, not an alkali, it is neutral. Aqueous solutions of sodium chloride, sugar, not acid, not base, it is a, okay, so they are your neutral, which are not acid, not nor a base, they are neutral. Examples: pure water, aqueous solution of sodium chloride, and sugar. They do not dissociate into their ions. They do not give H plus. They do not give OH minus ions. They are not corrosive, right? They do not turn litmus paper red or blue, so they are neutral. Now this is a pH scale. We can determine which is an acid and which is an base by using the pH scale. Okay, so you can see that this scale is up to 14. From 7 to 14, these are my pH numbers for alkaline solutions. From 0 to 1, these are my pH numbers for acidic solutions. The smaller the number, more acidic the solution, and the larger the number, more alkaline the solution. So an acidic solution, it has a pH number which is less than 7. If I say pH is equal to 4, so you should say that it is acidic. Alkaline solution has a pH number greater than 7. And a neutral solution, it have a pH of 7. Okay, so remember these things. Draw this pH scale and write down this thing. And tell me that which is more acidic. pH is equal to 1 or pH is equal to 3. Which is more acidic?
Sorry, ma'am,
Yes.
I was having some network problems.
Okay, so we are discussing pH scale. So have you got it, or should I explain it again?
Oh, no, I got it, ma'am.
So tell me which one is more acidic, pH is equal to 1 or pH is equal to 3?
pH is equal to 1.
And which one is more basic, pH is equal to 10 or pH is equal to 11?
pH is equal to 11.
Yes, you got it. Okay. So have you drawn this?
Yes.
What about you, Silasemba? Done?